just a little bit of information about this form. There are two asymptotes that we find. The one is the x equals. That's called the vertical asymptote. We talked about that one yesterday. The way you find it is by taking the denominator part, that's this piece here, setting that equal to 0, and solving for x. So the way you find a vertical asymptote when it's in this form, when you have a x on the top and x on the bottom. To get the vertical asymptote, you're going to take the denominator, solve the little equation for x. That'll be your vertical asymptote. The reason the asymptote exists there, an asymptote tells you that your graph can't have a number there. The equation can't have a value there. So if I plug a number in here that makes it 0, which in this case, what number would make this 0? 1. My asymptote then occurs at 1 because 1 is the value that's making the denominator undefined. So an asymptote is in your graph because it can't be that value. That's why an asymptote's there. So whatever number makes the denominator 0 is creating our vertical asymptote. So the first step here, to graph something like 4x minus 2 over x minus 1, the first step is to draw the asymptotes and find out what those asymptotes are. So for the vertical asymptote, we're going to solve this little equation. So x minus 1 is equal to 0. We just said that if we solve that, you get x equals 1. So the vertical asymptote is found by taking the denominator, setting it equal to 0. And that'll be the same for all of the graphs we do next week. So that part isn't changing. So once you know that the denominator gets a vertical asymptote by setting it equal to 0, that'll never change with any of the graphs we look at next week. The second part would be the horizontal asymptote. That's the part that usually shifts the graph up or shifts the graph down. That was the k value before. So yesterday's problem, the problem that Virginia did, had a horizontal asymptote that was plus, I don't know what it was, we'll say plus 2. But whatever that extra value was added to the fraction, that was the horizontal asymptote that moved the graph up or down. Well, this doesn't have a situation like that because there's an x on the top and an x on the bottom. So the way we find the horizontal asymptote is by taking a divided by c. Well, if you look at a and c, a is the number in front of x on the top, c is the number in front of x on the bottom. So the horizontal asymptote is created by the number with x, the coefficient with x. So in this case, the a in front of x is 4. The c, which is in front of the x on the bottom, is 1. So it's not difficult to calculate, you just have to remember how to get it. So the horizontal asymptote is found by taking the number in front of x on the numerator divided by the number in front of x on the denominator. And if we reduce those, that gives us a 4. So the horizontal asymptote would be at y equals 4. So we have a vertical one and the horizontal one. And we're going to graph those first before we find the other points. So if you go underneath to the graph, we're graphing the vertical horizontal or the vertical asymptote, a dashed line, x equals 1. X equals is always a line that goes up and down. The vertical one is done with x equals, so the horizontal y equals 4, so now we're going left and right, so count up to 4 and make your dashed line going left and right. So we still have a vertical and horizontal asymptote, we just found them a little differently than we did yesterday. So the vertical is found by getting the denominator equal to 0, the horizontal one is using the number in front of x in the numerator and the denominator. The next step is to pick points. So first you think about your asymptotes. The second step would be to pick some points. There's only 4 chosen up here, so if you want to choose 4, that's fine. We'll do the next problem and we'll just pick 4 as well, kind of show you how to get those values. But you could still work on choosing 3 for each side. So that's up to you. But you still need a couple on the left of the asymptote and a couple on the right. So if we're to the left of 1, that's why a -1 and a 0 are chosen. Because 1 is the asymptote, so if I'm left of that, less than that, we would use a 0 and a -1. Or we could use a -2, a -3, a -4, but anything to the left. And then the points to the right have to be bigger than 1, so that would be a +2, a +3, a +4. So see if you can plug these in. Yes, use the calculator to help you. I mean, I think you could probably do it mentally because it's a fraction, so you're just taking a number divided by another number. So feel free to try and plug them in and use the calculator for help. But you're taking the -1, plugging it into the top and the bottom. Virginia? So Virginia said 2. And then you're plugging in a 0 to the top and the bottom. Are you sure it's 2? I think it's 3. I think the next one's 2. I think it's -1, 3, and then 0, 2. And then you're plugging in the +2 and the +3. So 4 times 2 is 8, minus 2 gives us 6. And then on the bottom, 2 minus 1 is 1, so that would just be a 6. Anybody have the last one when you plug in a 3? A 5, nice. So we have the asymptotes. That's going to be a guide to finish the graph. Yes, you have to graph the asymptotes. They're part of the graph. So make sure you are graphing them. And then plot the points. So you're only plotting 2 points. That's the tricky thing, and those 2 points are pretty close to each other. So you have to now realize that the graph is going to be curved, and it has to skim along the asymptotes. So the asymptotes are there to be guidelines for your curve. So when you connect those 2 points, make sure you're curving it towards the asymptotes then. That creates that branch. So on the other side of the asymptote, we have a 2 and a 6, and then a 3 and a 5. Again, they're really close to each other. It's just 2 points that you're using to graph. So a third one might make it a little nicer or easier for you to see what the curve would look like. But curve it with those 2 points, and then make sure you're going toward the asymptotes. So to create our 2 branches. So your graph should always look like 2 branches, 2 curves. Those curves should be identical. They're symmetrical. So they should be opposite of each other, flips of each other, mirror images of each other, whatever words you want to use there. The last part, yours is underneath. I'm just going to write mine above or next to it so we can kind of see what's going on up here. So the domain and the range. The domain would be left to right. If there are 2 branches or 2 parts of the graph, you should have 2 values for the domain, 2 values for the range. So looking from left to right, what would the domain be? Caitlin, what do you think? Right, so -infinity to 1, 1 to infinity. So the domain uses the vertical asymptote. So the vertical asymptote is part of the domain every single time. The domain will have the vertical asymptote in it. And then Caitlin, what's the range? Right, and 4 to infinity. And the range, these numbers here, are the horizontal asymptote. That was y equals 4, so that's helping us get the range. So it's going from -infinity up and stopping at 4. It'll get really close to it, it'll approach it, but it'll never touch it. And then on the other side, it's going then up above 4, and then it goes to infinity. Questions? So I'd like you to flip the page, because I'm going to graph one more that's like this, and at the top of the next page there is a final graph that is almost identical, just different numbers. So graph y equals -2x plus 1 divided by -x minus 2. State the domain and range. The first thing we need to find would be the asymptotes. I will use VA to represent the vertical asymptote pretty much from now until we're done graphing these. So when you see VA, that's our vertical asymptote. Does anybody remember how we find that from the previous page? Page.
You do -2x plus 1. -x minus 2.
Yeah, so it's the denominator that's not allowed to be 0. So that's why we're solving that little equation there. So take the 2 to the other side. divide by negative 1. The vertical asymptote is at negative 2. So that means this is counting by 2, so be careful. Counting by 2s, we have a vertical asymptote at negative 2. And then the other one, the horizontal asymptote, how do we find that? So that's y equals, because it's moving the graph up or down, is a
Negative 2 divided by negative 1.
yeah, negative 2 divided by negative 1. Which is 2. So the horizontal one is a divided by c. The number in front of x in the numerator, the number in front of x on the denominator. So that would be just 2. So at positive 2, we're moving up and then drawing our horizontal asymptote. And then the last thing we have to do is get some points. So when you're choosing points, look at where your vertical asymptote is. It's at negative 2. So you need a couple points to the left and a couple points to the right. If you pick 2, I strongly suggest you pick 2 that are a little spread apart. Because if you look at the last one we did, those 2 points were really close to each other and it was kind of hard to see what the graph or the curve was supposed to look like. If you pick points that are spread apart a little more instead of right next to each other, then you at least have a value to connect with that might be lower or higher than the other. So, what's up here? So we have a negative 2x plus 1. Because of that plus 1, like maybe we'll pick odd numbers. So a negative 7, or you could use a negative 9. But the plus 1, that plus 1, if we use odd numbers, it'll help with that plus 1. And then it needs to be less than negative 2. So negative 3 is 1 less than negative 2. Again, you don't have to pick these points, but I'm saying pick 2 that are at least spread apart from each other. So negative 3 and negative 7 are a little more spread apart than if picking negative 3 and a negative 4. They would be really close to each other. And then we need 2 values on the right. So I need values that are bigger than negative 2. If you want to pick a 0 is an easy number to plug in. And then maybe a 3 or a 4 or a 5. It's something a little farther away from 0. So like 3, 4, 5. Like the numbers are up to you. I'm just trying to get you to kind of think like what numbers should we pick. Pick numbers that maybe are a little more spread apart than just them being like a 1, 2, 3, 4 right next to each other. So please plug them in. I'm going to pass out your folders and then I'll start passing out your tests. Plug them into the equation. Most of these should be whole numbers. Anybody have a number when you plug in a negative 7? Maddie, what do you have?
3.
Awesome. Do you have the other ones, Maddie?
Negative 3 is 7. I didn't do 0. I did negative 1.
You did negative 1?
Yeah.
Okay.
And then 3 is 1.
3 is 1. So if you just look and plug in a 0, plugging in a 0 I like to use, you don't have to, but when you plug in a 0, it makes the x's go away. So if you plug a 0 in, you get 1 and negative 1 divided by negative 2 or negative 1 half. Maddie, what did you get when you plugged in a 1?
A negative 1?
Yeah.
Negative 3.
Negative 3. So that was a nice number too. If you chose to plug in a negative 1, you'd have gotten a negative 3, which is a pretty nice number. So going to graph these, make sure you're counting by 2s. So those points are a little spread apart, which just makes it a little easier to graph. So now we're connecting these 2 points to get that first curve. Again, counting by 2s here. So if you're graphing 2 points, connect those 2 points, make it curve next to your axis, next to your asymptotes. Questions? So I have a worksheet. I have the graph paper out. I think most of you picked up one when you got home, when you came in today. There are graphs on here, but they're tiny and they're all counting by 2s. And I just think it's easier to graph when you're not counting by 2s and you have a larger graph. So you don't have to use the graph paper you picked up. It's just a suggestion. If you like to graph on here, you can. You can put your t-charts on here and make sure you're staying the domain and the range. The answers are on the back. So there's 6 that you're graphing. There's 6 problems that you're just determining the asymptotes. So you're given equations, you just have to find what the asymptotes are. And then there's a little word problem down below that also has a graph for you. So again, answers are on the back. If you look at the equations from 1 through 6, which one of those equations was yesterday's form? Number 1. So number 1 was the HK form. The rest of them, 2 through 6, it was the form we talked about just now. I mean, you can kind of look at the numbers and like if they're even, maybe you want to pick even numbers, but just pick 2. If you pick 2, pick them so that they're not right next to each other. So pick a 2 and a 5, or a 3 and a 6, so that they're a little spread apart. But there's no way to kind of look besides you graphing a whole bunch. You might realize what numbers might be better, but it's okay if you have fractions or decimals, Erin. Like that's all right. They don't have to always be whole numbers. I'm gonna try and get these tests passed out to you fairly quickly.
The inverses, I just wrote stuff down. So it's like, I put the extra slash and be what did you do? I just was like, yeah, this is right. That's kind of smart. So, I don't know. I was just like, Oh, so no, I'm not gonna get that y from down here, because usually if it's just where you square root it, you can't y root it. You can't y root it. Actually, you might. Does it make sense?
I don't say time. I say
Virginia, my daughter drew you a smiley face because she was next to me, so that's why you get a special one. You were the only special one. When I was grading her, I stopped after she sat next to me. So that's why you have the crazy face.
Yeah, there's no way I can put them there. I'll think of mine. Mine looks like it has an ear. Yep. On Friday, March the 2nd. So last Friday. I wasn't there, and there was no makeup test in the absent order form. But it says on the bottom that I'm missing a test. It was, holy, I don't remember. Yeah, I feel like my 98 to a 96 because I had a really on ER, YER, LER, and a 3 to 12.
yeah, I got it. 1.1.
And there was nothing. And there was nothing in like the absent order.
Please let me know if you have questions that I can
Is it the calculus?
Yeah, that was the day, I think it was our class that did.
Great.
Because we got yelled at for being.
Oh, yeah, it's the, yeah.
I wish I was in your guys' class.
Our class is terrible.
It gets
I like
annoying.
4 people in our class.
Look at the Isley and Riley.
Everyone. No, you love Andrew.
I like Andrew. I hate Riley.
I'll read it all.
I don't show it all.
You, Bella, and Morgan, and.
I just don't enjoy it. I didn't enjoy that.
So yes.
It'd be so weird and so I have no hilarious. You're like my closest friend.
Any other questions? Is that you question you stretching?
Oh, I'm just.
I hate that.
I hate mine. Okay.